Well, good evening, everybody, and welcome to the third in a series of many, hopefully, live moon tours brought to you from the Frank Bash Visitor Center at McDonald Observatory. We are part of the University of Texas. My name is Kevin Mace, and I am part of our outreach team here. We do hope to see some of you visiting us in the future. We don't yet have an opening date. For the latest updates on that, do visit our Facebook page, other social media pages. We'll give you the latest up-to-date information on that, in addition to our website at mcdonaldobservatory.org. Did want to let everyone know who's watching the stream tonight, we are going to be taking your questions in the chat, and we are going to save, our moderators are going to save a few of those questions for me to take at the end of our program tonight. So don't wait until the last minute to get your question in. Those will be answered throughout the stream tonight. And again, I wanted to welcome all of you to our third live moon tour for this series. Now, if you joined us on Tuesday, we saw some pretty amazing features on the moon, but that is nothing compared to some of the stuff that we're going to see tonight. So I hope everybody out there is ready, and we're going to start our program here with a view of where we are. We always like to start for our first time visitors to the stream, showing you where we are located out here in far west Texas. This is the summit of Mount Locke. This is the highest point on our campus here at the observatory. You can see on the left there the 82-inch Otto Struve telescope. That was the first telescope put here back in May, dedicated in May of 1939. The large telescope just to the right there is our 107-inch Harlan J. Smith telescope, which is currently the second largest telescope on our site. If you look in the background at that other mountain back there, that telescope looks a lot smaller, but it's a lot further away. That is a 10-meter, that's about 400-inch telescope, and that is the largest telescope on Earth that is currently engaged in active research. We are 450 miles to the west of Austin, out here in the beautiful, beautiful Davis Mountains. Also wanted to show you an aerial flyover here of our visitor center, the Frank N. Bash Visitor Center. You can see the domes out there behind the visitor center. I am in the one circled in yellow. You can also see our amphitheater out behind the building there. That's traditionally where we start our Star Party program. And like I said earlier, we do hope to have some of you back on site here in the future, visiting us for a Star Party. Wanted to briefly go down some of the topics that we're going to cover tonight. We're doing the introduction at this time. I'm going to show you the equipment that we're using tonight to observe the moon. We're going to take a breakout session to look at the moon, the live moon, in a low power setting where you can see the entire moon in the field of view, along with some of its major features. Our section in the middle that I call our discussion session is what is going to be different about each and every one of our moon tours. And tonight we're going to talk about something that most of you have experienced before and some of you already know about, called the moon illusion. We're also going to spend a little bit of time talking about a spacecraft that orbits around the moon, has been there for about 10 years or so, that is mapping the moon and allows us here on the Earth to have amazing imagery of the moon to share. And a lot of the content, or at least some of the content that you're going to see tonight, is actually LRO data. We're going to do our live tour, high-power tour of the moon tonight following our discussion, a little Q&A session after we're done with our live moon tour this evening. We're going to round out the program tonight as I'm taking some of your questions, by also giving you some resources for further learning about the moon. Let's get to where I am specifically. I'm in this dome right here. I took this picture on Tuesday night for our Tuesday night program, just right before the program began. I took that picture there. Inside of that dome are two telescopes. Now you obviously see the large one in the picture. You can also see the back end of it right here. That is a 16-inch telescope. We're going to use that telescope tonight to get our high-power views of the moon. But you might have noticed you can see another telescope right here, and you can see it in the picture as well. That is a 3-inch telescope. It's a short-focus refracting or lens-type telescope that we will use tonight to get some awesome low-power views of the moon. All of this telescope equipment rides on something called a telescope mount. that is what allows the telescope to move and what allows it to track across the sky as the Earth spins. The mount is made by a company called Software Bisque, located in Colorado. And this is an older model of theirs, but a workhorse of astronomy called the Paramount ME. Now look in that picture there. On the back end of both of those telescopes is a small device that has a cable coming out of it. Those are our small cameras tonight that are made by a company called Point Grey Research. And we're using two different models of their cameras tonight that are best suited to the respective telescopes on which they're located. Now, I always say this to folks during our live stream, mostly because we're using the telescope system here that costs tens of thousands of dollars. I always like to remind people that you certainly do not need a tens of thousands of dollar telescope to get a good view of the moon. Now, for those of you who have tuned into all of our live moon tours so far, I show off a different telescope of mine in each program. The first I showed off on May the 3rd. That was my first telescope, a very small 60 millimeter telescope. Tuesday, I showed you my 4-inch telescope. The one that you're seeing here in this picture is my 10-inch telescope that I got back in late 1983 and first took to Texas Star Party in 1984. And when you start getting into an instrument, 8, 10, 12 inches in size, the moon is certainly a good target to look at, but you have to use a filter because the mirror in a 10-inch telescope collects a tremendous amount of light. And you're going to need to have a little neutral density filter in the bottom of that eyepiece to make the moon comfortable to look at. All right, so just a reminder, you don't need a super high power telescope to do what we're doing tonight, getting good sharp views of the moon. Speaking of which, I want to show you now the live moon. This is, in fact, a live image, and I'm going to center up that moon in our screen there a little bit better for you. Now, this is what we call a low power view or a low magnification view. I always pretty much prefer these views of the moon because you can see the whole moon, you can see the features on the moon, and in the context of seeing the whole thing, you can get an idea about how big the individual craters are and other features compared to the moon itself. Now look at that image. I wanted to tell you about a few things that you're seeing there, and let's start with those big dark patches. I'm going to put a little pointer up here on the screen for you. You've probably noticed there are several dark patches on the moon, and certainly, you've seen those on the real moon outside before. If you've never seen the moon in the sky before, you need to get out more often. But I'm showing you close-up views here, and these dark patches, like I see one here and here and there and there and there, those are what we call the lunar seas or the Maria. Now, they're not actually bodies of water, but they once contained lava. Impacts on the moon and some limited volcanism on the moon created a lot of liquid rock that would flow down into the low points of the moon and fill up those basins. And we call them seas because they do sort of look like water. Now, we've known they're not filled with water for hundreds of years, but by the time we knew they were not water, we had been calling them seas for so long, well, the name had kind of stuck. And I want to point out a few specific ones that we're seeing tonight. One that we featured on Tuesday night right here, this big oval on the edge of the moon, is called the Sea of Crises. Up here, we have the Sea of Serenity. Below the Sea of Serenity, sort of shaped like Pac-Man right here. That is one you've heard of before, the Sea of Tranquility. The one that's over to the right of the Sea of Tranquility right here, that's the Sea of Fertility. The Sea of Nectar is down here. And you don't see much of it tonight, but right here, defined by these mountain ranges, we're seeing just a little bit of the largest sea, the largest impact basin on the moon, that is known as the Imbrium Basin. We're going to be talking about that a little bit later on in our high power views. Now, in addition to those big dark patches on the moon, the Maria, you've probably noticed there's lots of craters on the moon. Look at the moon for a second and notice where you are seeing those craters the best. In other words, where does it look roughest on the moon? And if you look around for a minute, you'll notice that there's not really that many craters visible over here on this part of the moon, but there's a bunch of them along this line that we call the terminator. Now, the terminator is simply where the sun is rising for a waxing moon or where the sun is setting for a waning moon. It is the terminator that defines the lunar phase. And whenever you look at the moon, the features that you'll see through a telescope or even through binoculars are going to stand out best when they're right along that terminator. If you go out and watch the moon over the next several nights, you'll notice that you won't be seeing a half moon, you'll be seeing sort of an egg-shaped moon that we call the gibbous moon. And you'll be seeing more and more of the moon's surface until about another week, and we're going to have a full moon. Okay, let me take you back to our slides tonight. We're going to come back and look at the moon, certainly. I wanted to discuss with you something that you've likely all seen before. Some night, some random night, you go outside and you look over to the east and you see the moon, and it's on the horizon, it's rising, and it's just enormous. I'm sure that all of you have experienced this before. The next time that you see that gigantic moon on the horizon, do an experiment. McDonald Observatory is a research facility, and we do science here. So do a scientific experiment. When you see that big moon, run in and get a ruler, unless you just happen to have a ruler on you. Okay, kudos if you do, I suppose. Go in and get a ruler and measure how big the moon looks, but measure it in a special way. Take your ruler and hold it out at the end of your arm. You're going to do 2 measurements of the moon, and you want the distance between your eye and the ruler to be the same in both cases. And when you measure the moon, you're holding your ruler out there at the end of your arm, measure the moon horizontally, not vertically. You see how that moon image appears a little bit squashed? It's like somebody sat on the moon. Well, atmospheric refraction, just the lensing effect of our atmosphere here on the Earth, makes the moon look smaller, but only in the vertical direction, only in the up and down direction. So go out and measure the moon when you see it gigantic like that. Write that number down, and then go out a little bit later, 30 minutes, an hour, doesn't have to be very long, when you don't see the moon big like you did before, and do your second measurement. When you compare those 2 measurements, guess what? It's the same. You should get pretty much within the measurement uncertainty, the same result. It's called the moon illusion. Now, a lot of people that know about such things have commented on why. Why does our eye and brain combination see the moon in this way? There's all kinds of optical illusions that can fool your eye-brain system. This is just another example of them. But there doesn't seem to be any strong consensus about what physically is actually going on, what perception problem we're having that makes the moon look that big. But now that you know that, the next time you see that giant moon, don't be fooled. It really is no bigger, it's just a perception problem. Okay, now I want to do something I've been looking forward to doing for a couple of weeks now, since I've been planning these live moon tours, coming up with new ideas, new things to show you. We're going to investigate the website for the Lunar Reconnaissance Orbiter. Now, I need to do a few things right here. Let me get a few resources up here. And what you're going to see next is the actual web page. We're using the web page live right now. Notice the URL, quickmap.lroc.asu.edu. ASU is Arizona State University. You can go to that URL. It'll take you to the same view that we have here, where you can do a number of things. Let's see, what shall we do first? Well, if you just want to have some labels on the moon, you want to know what is what, you can go over here to where it says layers, and you can turn on nomenclature, names of things, basically. And if you click the little down arrow right there, you can filter the types of things that you want to see. Like if you only want to see craters, you can filter by craters. If you only want to see mountain ranges, you can filter by that. So there's a lot of selection that you can do. I'm going to turn that off. Another thing that you can do that's pretty helpful is to turn on what they call the sunlit region. Basically, we're reproducing the phase of the moon that we have tonight. Let's see. Oh, I wanted to show you something else you could do. There's a couple of different views that you can use of the moon. This view, you can zoom up on it like this. And you can pan side to side and cover only the Earth-facing side of the moon. You can't look at the back of the moon in this view. But if you go over here under the little globe, you can switch your projection from just seeing the near side to what they call lunar globe 3D. I'm going to turn that on. You'll see our moon reappear there with our phase. Let me get rid of that window there for you. Now this view is kind of cool because what you can do now is you can go all around the moon. You can pivot all the way around to see the back side of the moon. There's the back side of the moon. Now that's not called the dark side. Some people do refer to it as the dark side, and it is the dark side, but only at full moon phase. The back of the moon, the far side of the moon, gets just as much sunlight as the side that we see does. But you can pan all around. You can go look at the poles. Now the polar regions look a little weird because of the way that the LRO maps its data. If you get lost and you can't find your way home, just click the home button and it will return you back to the view where you started. Pretty cool. In fact, let me show you a couple of little animations here, because it turns out the LRO has been in orbit around the moon for quite some time. Let me get my picture out of the way there. The LRO was launched from Earth in June of 2009. It entered orbit just a few days later, on the 23rd of June, 2009. The mission, which is LRO plus the LCROSS mission, which were both launched at the same time, those cost about $500 million. The current orbit of the LRO is a long elliptical orbit, about 100 by 12 miles or so. And the LRO spacecraft has mapped 98% of the moon at 330-foot resolution. That's 100 meters. And NASA engineers estimate that it has about enough fuel for 6 or so more years of operations. Now, the way that LRO orbits the moon is in a polar orbit. It doesn't orbit parallel to the equator. It orbits above the poles, north to south and south to north. And keep in mind, it's really close to the moon. And so it only sees from its close position there a little narrow swath of the moon at one time, and it images that area passing underneath it. And over time, it's been there for 10 years, over time, that allows it to build up this nearly global map of not only positions on the sphere, but also elevations on the moon. And that, of course, would allow you to go back and reconstruct those data and seemingly walk around on the moon. I'm going to show you some views in a minute that are sort of like that. So that is a really cool thing, I think. And before we move on, I want to show you something really, really cool. I'm going to go back to the normal projection, the one that will start you out at when you go to the website. And just because it's a little slow sometimes to draw that phase, that sunlit region for us, I'm just going to turn that off. And I'm going to zoom in to some mountains that we're going to talk about here very, very shortly. Now, as I zoom and zoom and zoom and zoom in, you're eventually going to see it look a little weird. Zoom some more. Zoom some more. There we go. Okay. When you zoom into a certain point, you do begin to see the individual strips that were mapped one by one. And I want to show you something in the corner of this strip right here. This one's mapped at higher resolution because, and I hope I can find it. That would be really embarrassing if I can't find it. I know it's right about in here somewhere. Oh, there it is. If you think you know what you're looking at there in that view, comment. Put a line in the comments. That is the landing site of Apollo 15. you see right here is the lunar module. Remember the car that they drove around? Well, they parked it right over here. That's where they left it. You can see the track over to it and where they walked around and drove around and covered large areas of the moon. That's pretty cool. We're actually seeing on the moon where the Apollo 15 astronauts lived. So sorry, moon hoaxers, we did actually land on the moon. Speaking of, let's go and look at that moon again. I am going to switch our view at this point from our low power view to our high power view. So give me just a moment to do that. We're switching from the 3-inch telescope to the 16-inch telescope. Hey, look at that. That looks pretty good. Now I need to go up to the top of the moon. That's where we're going to start tonight. We're going to start pretty near the north polar region of the moon this evening. How about if I do that a little faster, Kevin? There we go. We're going to start up here with a nice pair of craters. Give me just a second to get everything lined up just the way that we want it. Now you're going to notice a lot of shimmer in this image, far less than we had on Tuesday night. This shimmer comes from the Earth's atmosphere. We're looking through the atmosphere, which is at different temperatures, at different altitudes. It's like a series of lenses that we're looking through, all with different focal lengths. And so that tends to make it look a little shimmery. I also would like to try to improve that view a little bit for you. There we go. Okay, I'm going to get my resource up here. There we go. All right, we are looking now near the northern part of the moon. We're beginning our program tonight in the lunar northern hemisphere, and the craters Aristoteles and Eudoxus welcome us to the moon. Let me show you Aristotle crater, Aristoteles crater, and Eudoxus crater right down there. Aristoteles up here is the larger of the pair and spans 54 miles. Its terraced walls descend a little over 2 miles to a relatively flat floor broken by a few scattered hills. The faintly visible raised sort of splat mark thing there you see surrounding the crater rim, that's composed of pulverized and partially melted rocks that form a raised mound known as an ejecta blanket. South of Aristoteles, we have Eudoxus down here. It measures 42 miles wide and is about 2.7 miles deep. Now, both these craters likely formed over 1 billion years ago because of the absence of bright rays that surround them. Geologists would classify this pair as Eratosthenean aged, meaning that they formed somewhere between about 1.1 and 3.2 billion years ago. Now, y'all probably noticed that we have some mountains in this view, and I'm going to move the telescope just a little bit down to the south so we can get all of the Caucasus Mountains here. 2 mountain ranges, the Caucasus and the Alps, are now present in our view. Let me get our pointer here to show you the lunar Alps are this range over here, and the lunar Caucasus is this range right here. We're not quite getting the tip, we'll catch that, the tip, southern tip of the Caucasus in our next view here tonight. Now the Caucasus and the Alps represent uplifted blocks of lunar crust that were raised about 3.8 billion years ago when an asteroid struck the lunar surface, creating the Imbrium Basin, which a little bit of that you can see here. This is the northeastern portion of the Imbrium Basin. Now, the actual size of that asteroid that created that basin is not known, but a recent paper suggested a diameter of about 150 miles. Let me pivot just a little further down here so you can see all of the Caucasus. There you go. The Caucasus Mountains do form sort of a broken spear point shaped range that runs north and south for about 300 miles. When we ascend from the lava plains of the Sea of Rains up to the highest point in the Caucasus involves an elevation change of at least 18,000 feet. So don't forget your oxygen, everybody. Although I suppose if you've arrived at the moon without a spacesuit, you have seriously failed to plan for this trip. What else do we have here? The Lunar Alps, just over to the west of the Caucasus. The Lunar Alps, and again, that is this section of the moon right here. The Lunar Alps stretch for about 175 miles and form the northern margin of the Sea of Rains, also known as Mare Imbrium. Now, did y'all notice in the Alps right here, did y'all notice this linear feature right over there? That's pretty noticeable. That noticeable gouge there crossing the Alps is called the Alpine Valley. Here we see a view from the Lunar Reconnaissance Orbiter QuickMap site that we visited earlier. This valley is a type of structural feature known as a graben. The floor of this 96-mile-long valley has dropped down with respect to the surrounding landscape. The change in elevation going from the bottom of the Alpine Valley up to the highest peaks in the Alps is about 13,000 feet. That's pretty amazing. I would really love to get that view of the moon sometime. Now, one of my favorite things about seeing lunar mountain ranges at favorable moon phases, which means basically low angle lighting conditions, is the amazing shadows that the mountains cast. Look at the shadows down here cast by the Alpine mountains. Look at those giant long shadows extending across the relatively smooth floor there of the Sea of Rains. That is just absolutely amazing. All right, it is time to move on to our second field of view tonight, our second view of the moon. We're going to travel just a little further south down the lunar terminator. And in this view, we're going to see some awesome mountain vistas. You're already seeing them there. Let me get things centered up a little better here for you. Okay. Now that we've moved southward down the lunar terminator, we are seeing one of my favorite portions of the moon, which includes an extensive mountain range and perhaps the most photogenic Apollo landing site of all of them. The crater Archimedes sits on the terminator and appears as a bottomless pit at this point in the lunar day. And you probably already spotted it, but this right here is Archimedes. It is about 50 miles wide and just a little shy of a mile deep. A faint trace of a lava channel known as the Hadley Rill can be seen just east of Archimedes crater. And yes, I am seeing it in my view, right along in here. The Hadley Rill. We're going to talk more about rills here in just a few minutes. As we move further eastward from Archimedes, we're now approaching the base of the Apennine Mountains. Now, from the Sea of Rains, most of which is in shadow over here, rising up to the summit of Mount Bradley. Here's Mount Bradley, right there at the tip of that finger. That's an elevation change of almost 14,000 feet, the highest point in the Apennine Mountains. Okay, we have 3 Apollo landing sites to show y'all tonight. I'm very excited to show you Apollo landing sites because we did not get to see any of them on Tuesday. They were all in shadow, but we have 3 to show you tonight. Apollo 15 is where we're going to start this evening, which landed right about in here. We're going to see that in a little bit different way here in a second. That's the Apollo 15 landing site. Astronauts David Scott and James Irwin landed near Hadley Rill on July 30th, 1971, while Al Worden orbited overhead in the command module. And this was the first mission to use the lunar rover to extend their exploration of the lunar surface. 3 EVAs, that's extravehicular activities, spanning 18.5 hours were accomplished during their nearly 67 hours that they spent on the lunar surface. Now look at the picture just to the left here, this big mountain in the background, that is known as Mount Hadley. And I want to show you a cool view, kind of like we did earlier using the LRO Quick Map site. That points right there, that arrow points to the Apollo 15 landing site. We saw that a while ago on the web page. Look at the mountain that's right above where they landed, just north of where they landed. That is Mount Hadley. So we were seeing it in the live picture, or in the picture they took back in 1971, and that is it, right above the Apollo 15 landing site. Awesome. We have now covered this portion of the moon. We're going to move further to the south and see some features that we have not yet had the opportunity to talk about during our live moon tours so far. Okay, we're going to move down here to the south. And I'm looking at my resource to try to get exactly where I want to be. Let's see, we need to go a little further over to the east. Yep, that's where we want to be. Now look around in that field of view, see if you notice anything a little odd. Having now descended down the eastern side of the Apennine Mountains, we enter the lava plains of the Sea of Vapors. I can show you the Sea of Vapors. It's right up here, also known as Mare Vaporum, and the Central Bay, right down here, also known as Sinus Medii. Now, Sinus Medii, the bay there, is located at the geographic center of the Earth-facing side of the moon. The crater that you see right here is called Treesnecker. And Treesnecker is the largest crater on the smooth plain separating the Sea of Vapors from the Central Bay. This crater measures 16 miles wide and about 1.5 miles deep or so. Numerous rills of different ages crisscross the plains north and east of Treesnecker. Now, rills, that's what I was trying to get y'all to spot. Did y'all notice this feature right here and that feature over here? Those are what we call rills. I'm going to leave my pointer right there because we're coming back there in just a minute. Rills are generally considered to be collapsed subterranean lava tubes that supplied molten rock to the lunar surface. When the eruption ceased, the lava receded from the tubes and they eventually collapsed to form the vein-like structures that you see there on the surface. Now, however, the Treesnecker rills don't seem to fit that pattern and may instead be structural features lacking an obvious volcanic component. The crater I'm pointing at now is called Hyginus. Hope I'm pronouncing that correctly. Hyginus. Most lunar craters form by impacts, but Hyginus is a type of volcanic crater known as a caldera. Notice that this 5-mile wide crater does not have a raised rim, as impact craters do. Let me turn my pointer off there so you can see that a little bit better. Notice how it doesn't have that raised rim around the edge. The crater and the rill name for it are both of volcanic origin. The Hyginus rill extends for 136 miles, or if you're a Texan, that's the distance approximately from Seguin to Katy, Texas. Now, volcanoes that collapsed to form calderas were once active out here in the Davis Mountains of western Texas. 30 to 40 million years ago, our region of the state was a flurry of volcanic activity. These volcanoes blew their tops near the end of their eruptive phases, flooding our area with lava and volcanic ash. Now, on the moon, the volcanic activity is much older. We do not know the precise age of the Hyginus system, but it's certainly fair to say that it is many, many times older than the volcanics of western Texas. Now we're going to take a little side trip. Everybody, a little road trip on the moon. We're going to go a little over to the east of where we are currently, and because I want to show you something that's pretty cool, and I think you'll agree it's worth taking this little side trip. We're now in the region where Apollo 11 landed, and I want to show you as closely as I can here exactly where they landed, which is right about at the tip of the pointer's finger, right there. Apollo 11 Commander Neil Armstrong and lunar module pilot Edwin Buzz Aldrin successfully landed their spacecraft, the Eagle, on July 20th, 1969, while Michael Collins piloted the command module called Columbia in lunar orbit. Armstrong and Aldrin were on the surface for a mere 21 and a half hours, of which 2.5 hours were spent outside the Eagle photographing the surface, deploying experiments, and collecting 47.5 pounds of rock and soil. One of the instruments placed on the moon was a laser retroreflector. At McDonald Observatory here, we have performed lunar laser ranging for decades with this device and 3 others, one of which was delivered to the moon by the Soviets on an unmanned rover. All right, I think y'all will agree it was worth taking a little side trip over there to see the Apollo 11 landing site one more time before we leave the region, right about there. Okay, now we're going to move on to our 4th field of view for you tonight. Going to move the telescope yet more down to the south and a little bit now over toward the west. We're going to see some very large craters in this view, so get ready. These are the largest craters that we're seeing on the moon tonight. Not the largest craters on the moon, just the largest ones that we're able to see tonight. Now that we've continued southward, we enter the ancient, heavily cratered southern lunar highlands. Here we see a landscape saturated with large, old, heavily eroded craters, representing an early period of intense bombardment of the lunar surface. Some of the largest craters here bear the scars inflicted by grazing debris ejected during the formation of the Imbrium Basin. Let me show you what I'm talking about right here. All these linear features, like here, these lines, basically. Linear features, that's a fancy way of saying lines. Those were debris blasted out of the Imbrium Basin, the Sea of Rains, during that impact event 3.85 billion years ago. The crater Ptolemaeus is the first big one here. The crater Ptolemaeus is 1.5 miles deep and almost 100 miles wide. And then right below it down here, we see the crater Alphonsus. Alphonsus measures 69 miles across and is about 1.5 miles deep. On March the 24th, 1965, the Ranger spacecraft, Ranger 9, televised 5,814 images in the last 19 minutes of its flight until the time of impact. Ranger 9 struck the floor of Alphonsus crater traveling at a speed of 6,000 miles per hour. I just love that video. It's one of my favorite things ever. What else do we have here? Remember, this is Ptolemaeus, this is Alphonsus. Right down over to the east a little bit of Ptolemaeus, we have the crater called Albategnius, which is 81 miles wide, has a really prominent central peak right there in the middle, rises up about 5,600 feet. Now that peak that you see in the middle, not only of Albategnius right here, but also in the center of Alphonsus, and our next one we're going to visit down here, those central peaks are part of the impact process. When an asteroid comes down and crashes into the moon, it makes a big hole, that's the crater, it explodes material out in all directions, and as it has compressed those layers of rock, they rebound back up a bit and form a group of mountains, literally in a few minutes, in the center of those craters, the very energetic impacts that make the large craters. Our friend down here to the south, whose central peak you can also see right there, the name of that crater is Arzachel, and it is the youngest of the 4 behemoth craters around the terminator that we're seeing tonight in this view. Arzachel measures about 60 miles wide, has a central peak, which is just catching the first light of sunrise. It's about 5,700 feet tall. With the exception of the younger craters like Arzachel, these old large craters have smooth floors and inter-crater areas that represent fine deposits delivered from the Imbrium impact. Now, these smooth plain deposits are formally known as the Cayley Formation. Cayley Formation. Now I want to show you another Apollo landing site. This one is always, for me, the hardest one to find, but I think I know where to take you. We do need to move over here just a little bit. Yeah, I know where we are now. Okay, Apollo 16 landed right about where the tip of that finger is. Now, Apollo 16 was the only mission to land in the lunar highlands instead of on a relatively flat plain. Their principal mission was to sample material from the Cayley Formation and a rough deposit known as the Descartes Formation. Astronauts John Young and Charlie Duke walked on the surface, while Tom Mattingly piloted the command module above. Their lunar module was named Orion, and it landed on April 21st, 1972, and spent 71 hours on the surface. They conducted 3 EVAs and collected 211 pounds of lunar samples, some containing the oldest moon rocks dated so far. I'm really proud of myself that I could remember how to find that, because that's not an easy one to do. How are we doing on time? Well, we need to move on. This last section we're going to look at is a pretty brief section of the moon in terms of discussion. There's not a whole lot to see down here, but I would be remiss if I didn't show you the southern polar region. Of the moon tours that we've done so far, the one tonight affords us the best opportunity of seeing this region right down within like 100 miles or so of the lunar South Pole. All right. That's pretty awesome down there. Now, further to the south, we're in some of the oldest highland terrains visible from the Earth. The surface is saturated with craters of all sizes and states of preservation. Most are very old, with a small number of younger, in quotes, craters scattered around. The first one I wanted to point out for you is called Curtius. That is not spelled the way you think it would be. It is Curtius, and Curtius is located right here. Curtius is the largest crater closest to the terminator, with most of its floor still sunlit. At 67 degrees south latitude from its position, the sun is still high enough to illuminate the 60-mile wide, 2-mile deep crater. Just down below Curtius, this crater, you just see the rim of it right there. That is the thinly lit rim of the Moderators crater. Moderators, M-O-R-E-T-U-S. It's right there on the terminator southwest of Curtius. We're going to go further south still. Now, notice this feature right here. That is just the side, just sort of the northeastern side of the wall surrounding that crater. And that is the ragged rim of a crater called Malapert, M-A-L-A-P-E-R-T, Malapert. Catches the fleeting sunlight there in this, our final view tonight. Now, Malapert is located at 84.9 degrees south latitude, and the crater's northern rim is only 120 miles away from the lunar South Pole. Now, since the moon's poles are only tilted about 1.5 degrees relative to the sun's direction, craters this far south always have their floors in perpetual darkness, have not seen any sunlight at all for billions of years. Wow, that was a whirlwind tour of the moon this evening. Looking at the clock, we're about 45 minutes into our stream this evening, which means it is time for me to take some of your questions. I'm just going to leave that beautiful image of the moon up there as I pivot over to my moderators who have been collecting questions for me during the stream this evening. Let's see, Pete Natty, forgive me. Oh, no, this is John Priesmeyer, I'm sorry. John Priesmeyer says, why doesn't the Ptolemaeus crater have a central peak? Well, that is likely, John, because that crater experienced some filling in of the very bottom part of its floor. Sometimes that can be in the form of lavas. Sometimes it can be in the form of finer material that settles down into the bottom of the crater. It raises the bottom of the crater up higher, and basically just submerges that central peak. Most all craters above a certain size do have that central peak, and the ones that are that size or larger that don't, typically something has happened after the fact to fill those craters in. Let's see, Dean Halverson says, is there a reason that certain areas have more craters than others? Yes. Do you remember, Dean, when we looked around at the back of the moon, the lunar far side earlier, when we were looking at the LRO website? The back of the moon is much, or appears much more heavily cratered than a lot of the front side of the moon. And again, that has to do not so much with the fact that there haven't been more impacts, or there haven't been as many impacts on our side of the moon. It's just that there are a lot more of those seeds. There's a lot more of those basaltic lava flows that covered up pre-existing craters. So when you look at our side of the moon, the Earth side of the moon, it is dramatically different in appearance than the other side of the moon, mostly because of the volcanic history on our side, on the Earth side. Okay, let's see. We are just about out of time. We've gone almost 50 minutes into our stream at this time. I did want to give you, before we go, some resources. If you want to continue to learn more about the moon, there are a number of websites here that you can visit. Stardate Radio and Stardate Magazine, those are productions of the University of Texas at Austin. And there are a lot of good resources on the Stardate website, including you can look up lunar phases, you can read articles about the moon, you can see what constellations are up in the sky, see a star map, all that kind of stuff. Stardate Magazine goes a little more in depth, actually quite a bit more in depth than the website generally does. Check out Stardate Magazine if you can. It's a very good resource for this sort of thing. NASA, we use a lot of their data tonight, and they do have a number of great resources for learning more about the moon. If you see the third link down there under the NASA section, that is the URL for the QuickMap site, the LRO QuickMap site that we visited tonight. That is your starting point for investigating the moon. I often tell people in my programs, before we shut down, we had a program called the Lunar Twilight Program, during which we talk about the moon quite a bit and go into it a lot of detail. I would always tell people that I have wasted several afternoons looking at LRO, the view of the moon from the LRO, because it's as close as I will ever get to going to the moon, let's face it. Also, Wikipedia has a number of good articles, well, one big article about the moon and subsections on Apollo and the Lunar Orbiter and the Lunar Surveyor, all the different spacecraft that went to the moon. You can visit those websites, learn more about that. And again, I wanted to thank all of you tonight for choosing to join our program. We're very, very thankful that you could be a part of this. I'm not sure if I mentioned this earlier, but our next moon program is likely to be in late June. We have not set the date yet for that next lunar tour, live moon tour, but it will likely be in late June. So keep an eye on our YouTube channel, subscribe if you can, keep an eye on our website. Also keep an eye on our website and our social media platforms for when we will reopen the visitor center for people to be on site. So thank you all very much. We appreciate your tuning in. I will see you again in late June. Good evening, everybody, and we will see you soon.